In today's class, we are going to see what is MRP1. MRP1 stands for Materials Requirement Planning. Materials are important resources for any industrial enterprise because without materials, no production will be possible. If we analyze the total product cost, it has got three major components: material cost, labor cost, and overheads. And in many industries, like in paint industry, 60 to 70% of the total product cost is because of material cost. The efficiency of an organization to a large extent depends upon the availability of raw materials at in right quantity and quality, and also at right place, time, and price. So it is very important to have a better control on materials in terms of sourcing, procurement, storage, material handling, and finally consumption. And materials management exactly does this. Now, one of the important aspects of materials management is materials planning. Materials planning, it is the scientific way of determining the requirements of materials, components, subcomponents that go into meeting the production needs within the economic investment policy of the company. By economic investment policy, I mean the budget. So within the budget, how much the company should be investing in its raw materials, or how much what is the requirement for raw materials in order to determine the production needs, or in order to meet the production needs, is done by material planning. Material planning is very important, as because if we don't go for proper material planning, either we will land up with over ordering or with under ordering. Over ordering means large amount of working capital will be blocked, and that is not profitable for an organization. It will bring the profitability of the organization. And under ordering is also not desirable, as because my production may come to a halt because of the unavailability of the materials. So material planning is very important aspect. Now, how this material planning is done? Material planning starts with business plan. A business plan is a statement of a company's overall organization's business activities. It is a statement of an organization's overall business activities for the coming 2 to 5 years. Considering the forecasted general economic conditions, then forecasted or anticipated conditions of the industry, as well as the prevailing competitive factors, the company decides how much company is going to invest in its business for the coming 2 to 5 years, and that is specified in terms of its business plan. The business plan in its turn guides the low level production plan, which is the production side of the business plan. The time horizon for a production plan is for 3 months. It is done monthly, and the time horizon is from 3 months or a quarter. Now, production plan is also called aggregate production planning, because at this stage, company decides what should be the level of output produced, or what should be the level of production in each of its product line. Company at this stage does not take into consideration what should be the production level at each of the product line details, right? So instead, company decides what should be the level of output to be produced in each of the product lines. So it is important that we further disintegrate the production plan into finer details with respect to each specific end item, and that leads to master production schedule. So production plan is further divided or disintegrated into its finer details, leading to master production schedule, which is with respect to each of the specific end items. Now, at this stage, it is very important to understand what is the difference between product line and specific end items. Okay, now let's explain this. The wide range of products which are offered by a company to its customers is called product mix. Okay, now the products which are offered by a customer, the product mix, that is the product mix, can be further grouped into its product lines. So product line is a group of products which are closely related, similar in nature, and sold to the same kind of customer base. For example, if you take the example Hindustan Unilever HUL, it provides a wide variety of product lines to its customers, starting from oral care, personal care, home care, food and drinks, water purifier, and many more. So each of this is called a product line. The number of product lines offered by a company to its customer becomes the width of the product mix. Now, if I take about the product line oral care, under this oral care product line, the company HUL offers two brands. One is Pepsodent, another is Close-Up. So the number of brands offered by a company to its customers, the brands are nothing but are the products with distinct characteristics. So under each product line, company offers a number of brands with distinct characteristics to its customers. So the number of brands under each product line is called the length of the product line. Similarly, if we take the product line personal care offered by Hindustan Unilever, then there are various brands which are offered by the company to the customers like Lidl, Dove, then your Breeze, Lifebuoy, Lux, Pierce, right? So all these are the different brands which are available under the product line personal care, and this brands, the number of brands decide the length of the product line. Again, if you take the case of a particular brand, for example, Lux in India, it's offered to the customers in different variants in terms of fragrance or size. So that becomes the depth of that particular brand. So product mix are characterized by its width, length, and depth. Now, when the production plan is designed, company decides what should be the overall production level with respect to each of the product line like oral care, personal care, food and drinks. So what should be the production level for each of the product line, that is decided in the production plan. But in MPS, the company decides what should be the production level with respect to each of the specific end items like Pepsodent, Close-Up. So these are the specific end items. So with respect to each of the specific end items, how much the company needs to be manufactured, by what dates they are need to be manufactured, that is mentioned in the master production schedule. So one thing we have understood, that production plan is with respect to each product line, whereas master production schedule is with respect to each specific end item. Now, in master production schedule, what we say, there are two important things: schedule quantities and the need dates. So in each master production schedule is for a specific end item, and it gives us two information, right? Like what should be the schedule quantities, means how many units of that particular specific end item are to be manufactured, and what is the need date, that is by what date they are to be manufactured. Okay, so we will see master production schedule, the structure of master production schedule in details. At this point, I would like to say one thing, that the end item, the specific end item, is said to have independent demand, whereas the components or subcomponents which go into making that particular specific end item is said to have dependent demand, because the demands of the components and subcomponents depend upon the demand of the finished product or the specific end item. So the demand of the components are said to have dependent demand. MPS looks like this, something like this. Now, this is a master production schedule for the end item X. So, if a company deals with 10 end items, there will be 10 master production schedule, each for its end item. So, this master production schedule is for the end item X, and how it is put or designed. It is designed week-wise, since master production schedule is stated in terms of from 3 months to 18 months. So here the master production schedule is shown for 3 months. As you can see, there are 12 weeks. Now weeks are there, and this is projected requirement. That means, as you can read from the master production schedule, that 200 units of X, the end item X, are to be delivered on second week. 400 units of X are to be ready by on 5th week. Similarly, 800 units of the end item X are to be ready by on 8th week, and 200 units of X are to be ready on 11th week. So this is how a master production schedule looks. Now based on this master production schedule, from here we get the information that 200 units of X will be needed in second week, and for that end item I must be needing some components and subcomponents. So through this MRP calculation we try to understand how many components and subcomponents will be needed to produce 200 units of X and when those components and subcomponents will be needed. Okay, so if you look here, we can see that MRP, it requires three inputs. One input from the master production schedule, which give the details for the end item, scheduled quantities and the need dates. Scheduled quantities means how many quantities will be needed, and need dates specify by what date they should be ready. So one input you get from master production schedule. Second input to MRP is BOM. It stands for bill of material, which is also called product tree structure, right? This tells us how many components, what are the components, subcomponents that go to make the finished product, in what quantity they will be needed, and what is the lead time to get each of the component. I will take an example of BOM, then it will be clear. And the third input to MRP is ISF, which stands for inventory status file. So all these three inputs help me to determine MRP, which is a backward calculation, starts with the scheduled quantities and need dates specified in MPS, and then finds out how many components and subcomponents will be needed and by what date they will be needed. So let's talk about BOM now, bill of material. So for that I have taken an example. Let's see. This, I hope this you can see, this is an example of bill of material for the end item X. So we have the master production schedule, now we have the bill of material, which is also called the product tree structure. As you can see, X is the finished product, which is composed, which is made up of components, immediate components A, B, C, right? The figures in the bracket or the parenthesis shows that how many components of how many number of components are needed of that needed to produce 1 unit of X, 1 unit of its parent item. So let's see this. This shows that I need 1 unit of A, 3 units of B and 2 units of component C to make 1 unit of X. Okay, so the figure in the bracket always show the number of units of that component which will go into making 1 unit of its end item, one unit of its parent item. Similarly, how to read this? This means 1 unit of D and 2 units of E are required to make 1 unit of A. And how to read this? If I ask you, then it should be read like this: 4 units of F and 5 units of G will be needed to produce 1 unit of C. So these figures are always with respect to 1 unit of the parent item. Okay, so this is given. Now the 2W, 3W, as you can see the figures, these are nothing but the lead times. So if I write here 2 weeks, that means 2 weeks is the lead time to manufacture X from its components A, B, C. Similarly, I have written here 3 weeks. That means 3 weeks is the lead time to manufacture A from its components D and E. And as you can see, E, the lead time is 3 weeks. That means we are not manufacturing E in-house, rather we are procuring E from vendors, and that procurement lead time is 3 weeks. Okay, so how to read this, we have understood. Now, based on the bill of material and based on the MPS, we determine what is MRP1. Now, each component, starting from the parent item, finished product, is given a level code in bill of material. The end item is always given a level code of 0. As you can see, it is always given a level code of 0. So X has been given a level code of 0. Now, components of n-1 parent, which are not common to any other subcomponent, will be given a level code of n. I repeat, components of n minus 1 subcomponent which is not common to any other subcomponent will be given a level code of n. So the components of for x component, the level code is 0. So A and C are the components which are not appearing anywhere else, and so they are not the subcomponents of which are not common to any other subcomponents. So they will be given a level code of 1 more than the parent item x. So x has been given a level code of 0. So A and C have been given a level code of 1. They have been given a level code of 1. Now just see B, I have cancelled it in order to make you understand that although B is an immediate child of X, but it has not been given a level code of 1 because it is also common to some other component, subcomponent G. B is common to some other component G. So since B is common to some other component G, B should be given a level code accruing to its linkage to the subcomponent and not X, right? So B should be given a level code depending upon the level code of G and not depending upon the level code of X. So as you can see, A and C have been given a level code of 1. D, E, F, G, since they are not appearing anywhere else, they are given a level code of 2 because their parent has been assigned a level code of 1. B is common here, which is common to G as well as common to X. So B has been given a level code of accruing to its linkage to G and not accruing to its linkage to X. So it has been given a level code of 3, and H is also given a level code of 3. So this level code YB, you may have the question that YB has been given a level code of 3 and not 1. See, if I have to procure B from a vendor, I have to, if I give the level code of 1, then, and if I again give a level code of 3 here, based on its linkage to its G, in that case I have to procure B twice, right? And if you procure B twice, there's a chance that you have to bear transportation cost, as well as you will not be getting any discount from the vendor. So what we do, we club the requirements of B and we place the order on the vendor at one go, so that there is a chance of getting discount, as well as we can have B when it is needed in order to manufacture G. Okay, so that is the reason we should be given, any item should be given a level code accruing based on its linkage to the subcomponent. So that's what's about, that is all about bill of material. And the third input to MRP is inventory status file, which is nothing but it shows the inventory level or amount of inventory for each of the components, subcomponents, as well as the parent item. So if I have to procure 200 units of B from my supplier, and if my present inventory status file shows me that there are 50 units of B is already available with me, in that case I have to procure only 150 units of B, right? Now let's take an example so that it becomes more clear how to go for MRP calculation. Suppose I have to, based on the bill of material, I have to manufacture 100 units of X in 15th week. That means 100 units of X are to be ready on 15th week, right? Now, so if, just see the bill of material, if 100 units of X are to be ready in 15th week, since 2 weeks is the lead time to manufacture X from its components A, B, C, so if you have to deliver X in the 15th week, when A, B and C should be available with you. Since 2 weeks is the lead time, A, B, C should be available with me 2 weeks before, that is in 13th week. Okay, and in what quantity they should be available? Just see, for 100 units of X, how many units of A will be needed? 100. For 100 units of X, how many units of B will be needed? 300. For 100 units of X, how many units of C will be needed? 200. Now, if I ask you, in order to manufacture 100 units of X, how many F will be needed? The answer is 100 into 2 into 4, that is 800. Similarly, in order to manufacture 100 units of X, how many G's will be needed? The answer is 100 into 2 is 200 into 5, that is 1000 units. So 1000 units of G will be needed, right? So this is what we have done. X will be needed in 100 quantity in 15th week. So A, B, C should be available in respective quantities in 13th week. 3 week is the lead time to manufacture A from its components D and E. So if we need A in the 13th week, when D and E should be available with us 3 weeks before, that is in the 10th week. And in what quantity? 100 into 1 into 1, that is 100 units of D, and 100 into 1 into 2, that is 200 units of E should be available to me in the 10th week, 3 weeks before A is to be ready. Okay, this is what how we have done this. So 100 units of X is liquid in the 15th week. For that I need A, C, D, these are the components and subcomponents, in what quantity they are needed, that is we have specified, and by what dates they are to be procured or needed. They are to be needed, that is also specified. And if they are to be needed in the 13th week, for example, if I need A in 13th week, when A should be, when the purchase order or the production order should be released for A. As you can see, from this bill of material, it is clear. From this bill of material, it is clear that A is not procured, rather it is manufactured in-house. So the lead time of manufacturing A from its components D and E is 3 weeks. So if A is to be available in the 13th week, D and E are to be available 3 weeks earlier, that is in the 10th week, right? Now, if D is to be available in 10th week, and as we can see from here, D is the item which is procured, which is from the vendor. So what is the time when you should place the order? Because the 2 week, as it shows that 2 week is the lead time of procurement. So if I need D in the 10th week, definitely D is to be, the order for D, the purchase order is to be released for 2 weeks earlier, so that, because 2 week is the lead time of procurement, so that by 10th week B should be available to me. That means if I need B in the 10th week, my planned order for D is to be released in 8th week. I should release my order in the 8th week, so that 2 weeks is the lead time. By 10th week I get the material D, and with this D I manufacture A, so that I can meet the scheduled quantities of end item X, that is 100 units, and the need dates, that is 15th week for my end item. This is how the MRP calculation is done. I need B because B is the subcomponent of X as well as B is the subcomponent of G. So if you do this calculation, one is coming to be 100 into 2 into 5 into 4, that is 2000. 100 into 2, 200 into 5, 100 into 2 into 5 into 4, 4000, and this way we are getting 300. So 4300 units of B are to be needed in which week? In the 10th week. And for that, since 2 weeks is the lead time for B, I should be placing the order for B in the 8th week. So through this MRP calculation, actually we get what is the scheduled quantities and the need dates for all the components and the subcomponents, so that I can meet the scheduled quantities and the need dates for my end item X, which is specified in my master production schedule. So the three inputs of MRP are MPS, Master Production Schedule, which give you details regarding the end item. The bill of material gives you the details regarding how many units of the components and subcomponents go into manufacture one unit of your finished product. Also the lead time of the components and the subcomponents, and the inventory status file give you the knowledge or the information regarding how much present inventory is available with you, so that you place the order of purchase order or the production orders are to be released accordingly. So depending upon this, outputs of MRP can be release of orders, either in order to make it in-house, in order to make the components in-house, or to buy the components from the outside vendors. Okay, so with this we come to the end of today's session. In today's class we started our discussion with the importance of material planning, and then we have discussed how this material planning is done. It starts with the business plan, which is done for a time horizon of 2 to 5 years. The business plan in turn guides the production plan. The time horizon for a production plan is monthly to 3 months or quarterly. The production plan in turn guides the master production schedule, which is done for the specific end items. The production plan, which guides what should be the overall level of production for each product line, whereas master production schedule guides that how much should be the production level for each of the specific end item. Then we have seen what is MRP1, how these calculations are done. The three inputs to MRP1 are master production schedule, bills of material or BOM, bill of material, and then ISF, which is called inventory status file. And the output of MRP1 is planned order release. If the components are manufactured in-house, then production orders are to be released, whereas if the components are to be procured from vendors, then the purchase order are to be released. So with this we come to the end of today's session. In the next session we will take an example so that you can understand how this master production schedule is built, how it is designed, as well as how the MRP1 calculations are done for the components and the subcomponents.